Hey everyone, welcome back to the channel. In this masterclass we are doing a complete, from the ground up deep dive into Spring Boot auto-configuration internals. By the end of this video you'll understand it well enough to use it confidently in production and explain it clearly in an interview. If that sounds good, make sure you are subscribed and let's get started. Auto-configuration is one of the most used and least understood features in the Spring ecosystem. We are going to strip away the mystery and follow the exact code path Boot takes every time your application starts. By the end of this section you will have a precise mental model of what is happening and why. Before Spring Boot, a single JPA setup required at minimum 4 separate bean declarations, a DataSource, a local container entity manager factory bean, a JPA vendor adapter, and a JPA transaction manager. Every team in an organization was writing essentially the same configuration, slightly differently, every time. That duplication was the direct problem Boot was designed to eliminate. The entire contract can be stated into sentences. If a library is present on the class path, Spring Boot will attempt to configure it with sensible defaults. If you provide your own bean of the same type, Boot steps aside and uses yours instead. That override mechanism is what makes auto-configuration safe to rely on in production code. Quick pause: if this is useful so far, drop a like, subscribe for a new masterclass every week, and share it with a teammate who would find it useful. Now, back to it. When you add a starter dependency, a metadata file inside that jar tells Spring Boot which auto-configuration classes are candidates. AutoConfigurationImportSelector reads that list and filters it through a set of conditional checks, things like whether a specific class is present on the class path or whether a particular bean already exists. Only the classes that pass every condition contribute bean definitions to the application context. 4 components do almost all of the work. The @enable auto-configuration annotation, which at Spring Boot application includes by default, activates AutoConfigurationImportSelector. That selector reads the imports metadata file packaged inside each autoconfigure jar to discover candidate classes. Each candidate is then guarded by one or more @conditional on pom.xml annotations that decide at runtime whether the beans should actually be registered. Understanding these 4 pieces is the foundation for everything else in this section. Spring Boot application is a composed annotation. It bundles 3 separate annotations into one. Components can handle your application classes. Spring Boot configuration marks the root configuration. But it is enable auto-configuration that fires the entire auto-configuration machinery. You can also see the exclude and exclude name attributes here, which give you a clean way to opt out of a specific auto-configuration class without touching any other configuration. This plaintext file, shipped inside the Spring Boot auto-configure jar, is the master list of every auto-configuration class Boot knows about. AutoConfigurationImportSelector reads this file at startup and treats each line as a candidate configuration class. Prior to Spring Boot 2.7, this list lived in Spring.Factories under the Enable Auto-Configuration key. You will still see that format in older starters, and Boot supports both formats for backwards compatibility. Auto-configuration is not magic, it is a precise, deterministic chain of decisions executed at startup. We are going to trace that chain from the moment your main method runs all the way to a fully configured bean in the application context. Every term we define here will reappear throughout the rest of this masterclass. These 5 terms form the skeleton of auto-configuration. Auto-configuration is the outcome, @enable auto-configuration is the trigger, AutoConfigurationImportSelector is the engine that reads the registry, Spring.Factories and AutoConfigurationImports are the registry itself, and @conditional is the decision mechanism applied to every single candidate. ConditionEvaluationReport is your diagnostic tool. When a bean you expect is missing, this report tells you exactly which condition failed and why. A starter like Spring Boot Starter Data JPA is purely a dependency aggregator. It contributes no configuration logic itself. It simply ensures the right auto-configuration module and its required libraries land on the class path. This diagram captures the entire pipeline in one view. Spring Boot application embeds enable auto-configuration, which delegates to AutoConfigurationImportSelector. That selector reads the imports file to build a candidate list. Each candidate is then evaluated against its conditional constraints. Those that pass become beans, those that fail are recorded in the condition evaluation report. A starter dependency sits outside this pipeline. It simply ensures the auto-configuration module and its imports file are on the class path in the first place. Spring Boot application is a composed annotation. It is shorthand for 3 separate annotations. The one we care about is at enable auto-configuration. When the Spring context starts, the presence of this annotation causes the framework to load AutoConfigurationImportSelector and begin resolving candidates. The other 2 annotations handle configuration class detection and component scanning, which are separate concerns. This is the registry file introduced in Spring Boot 3. It lives under meta-inf Spring inside the AutoConfigure jar, and each line is a fully qualified class name that AutoConfigurationImportSelector will load as a candidate. In boot to the equivalent was the spring.factories file under the key enable auto-configuration. The format changed but the concept is identical, a flat list of candidates to be evaluated. DataSource auto-configuration is a concrete example of every concept we just defined. The class level conditional on class ensures this configuration is only considered when DataSource is on the class path. Conditional on missing bean at the method level means the auto-configured bean is only registered if you have not already declared your own. This is the fundamental contract of all auto-configuration, opinionated defaults that step aside the moment you provide your own. The golden rule is that auto-configuration is entirely opt-out, not opt-in. The conditional system guarantees that any bean you define explicitly takes precedence over the auto-configured equivalent. Understanding this rule resolves the majority of why is Spring Boot ignoring my configuration questions before they even become debugging sessions. The number one source of confusion about auto-configuration is not knowing when it fires. Before touching a single conditional annotation, we are going to walk the entire Spring Boot startup sequence and pin down precisely where auto-configuration slots in. Every Spring Boot application starts with this same call, springapplication.run. You write it once and largely forget it, but it kicks off a very deliberate sequence of phases. Understanding those phases is the key to understanding auto-configuration. These 5 phases execute in strict order. Environment wiring happens first, context creation second, your primary source registration third. All the interesting work, including auto-configuration, happens inside refresh context. Actual bean instantiation only comes last, in finish beyond factory initialization. The first 3 phases are preparatory. By the end of prepare environment, the environment object holds every property value that conditionals will later interrogate. The context created in phase 2 is just an empty container. Phase 3 registers your application class as a source, nothing is passed or instantiated yet. Refresh context is where everything happens. It triggers ConfigurationClassPostProcessor, one of the most important classes in the entire Spring framework. This post-processor uses a configuration class parser to walk every configuration class, and it is inside that parser that auto-configuration is discovered and loaded. When the parser reaches your Spring Boot application annotation, it finds enable auto-configuration, which carries this import. That import brings AutoConfigurationImportSelector into play. But the critical detail is what kind of import selector it is, and that distinction changes everything. A regular import selector is processed immediately, in line, the moment the parser encounters it. A deferred import selector is held in a queue and processed only after every regular configuration class has been fully passed. AutoConfigurationImportSelector implements deferred import selector, so auto-configuration always runs last. Because AutoConfigurationImportSelector is deferred, by the time it runs, Spring already knows every bean the developer has registered. Conditional on missing bean can look around, see a data source is already defined, and simply skip its own. That deferral is not an accident, it is the precise mechanism that lets developers override any auto-configured bean by just defining their own. Let us open the annotation you put on every main class and understand exactly what each part does. 3 meta-annotations compose it, and each one pulls significant weight. By the end of this section you will know precisely what fires when your application starts. Strip away the Java annotation housekeeping and you are left with 3 meta-annotations: Spring Boot configuration, enable auto-configuration, and component scan. Everything Boot does at startup flows from these 3. Let us take them one at a time. Spring Boot configuration is essentially at configuration with extra semantics that matter to Boot's testing utilities. Enable auto-configuration is the protagonist. It is what starts the auto-configuration engine. Component scan handles your own application classes, and its exclude filters ensure that auto-configuration classes already loaded by the import mechanism are never registered a second time through scanning. Because component scan uses the main classes package as its root, placing your main class in com.mycompany.my app means every subpackage beneath it is discovered automatically. Move the main class into a subpackage and sibling packages become invisible to the scanner. Knowing this mechanism removes an entire category of confusing startup failures. Enable auto-configuration itself contains just 2 declarations. Auto-configuration package registers the main classes package so that subsystems like JPA know where to scan for your entity classes. The import of AutoConfigurationImportSelector is what actually drives the auto-configuration discovery pipeline. That selector is what we will trace through now. The public entry point is select imports, but all meaningful work is delegated to get auto-configuration entry. That method runs a sequential pipeline: load candidates from disk, remove duplicates, collect requested exclusions, validate those exclusions, run conditional filtering, and finally broadcast an import event. Each stage has a distinct responsibility. We will walk through the most important ones. Get candidate configurations reads a plaintext file from the class path. In Spring Boot 3.x, that file lives at meta-inf-spring org.spring-framework.boot.autoconfigure.autoconfiguration.imports. In Boot 2.x, the same data lived in meta-inf-spring.factories under the enable auto-configuration key. The result is a list of fully qualified class names, every auto-configuration class that could potentially apply. Unzip the Spring Boot auto-configure jar, and this is what you find: a plain list of class names, 1 per line. The real file contains well over 100 entries. Every name here is a candidate, not a guarantee. Nothing has been loaded, no conditions have been evaluated yet. This is simply the full menu of what Boot knows about. The filtering stages that follow are what trim it down to only what your application actually needs. After the candidate list is assembled, Boot runs it through several fast cleanup stages. Deduplication handles the case where multiple jars on the class path declare the same auto-configuration. Exclusion processing then removes anything the developer has explicitly opted out of. The filter stage is the most powerful. It uses pre-computed condition metadata to eliminate candidates before any class is actually loaded into the JVM, keeping startup performance high. The conditional annotation system is what separates Spring Boot's auto-configuration from naive, blunt bean registration. Every decision about whether a bean gets created flows through this machinery. We will go through every major conditional annotation systematically, understanding not just what each one does but why it exists. Before full conditional evaluation even begins, Spring Boot runs a fast filter pass. Rather than instantiating every candidate configuration class to check its conditions, it consults a pre-computed metadata file bundled inside the Spring Boot auto-configure jar. If the required class path classes are absent, the entire auto-configuration is eliminated from the candidate list without ever being loaded into the JVM. This is what an entry in the pre-computed metadata file looks like. For DataSource auto-configuration, the file declares upfront that javax.sql.datasource and embedded database type must both be present on the class path. The filter reads this file, checks the class loader, and silently drops any candidate whose required classes are missing, all before a single configuration class is instantiated. The pipeline has two distinct evaluation phases. The fast filter runs first, using only the pre-computed metadata and the class loader, no class loading, no reflection on configuration classes. Whatever survives is sorted by ordering annotations, then handed to the configuration class parser, which performs the full, per method conditional evaluation. Understanding this two-phase design explains both Spring Boot's startup speed and the sequencing rules you need to follow. Every conditional annotation in Spring Boot ultimately delegates to an implementation of this single interface from Spring Framework core. The condition context parameter is the power source. It gives you access to the bean definition registry, the configurable listable bean factory, the environment for reading properties, a resource loader, and the class loader for class path checks. One method, two parameters, unlimited extensibility. Conditional on class guards an entire configuration class based on class path presence. If DataSource or embedded database type cannot be found, the whole class is skipped. There is a critical gotcha at the method level. Never use a class literal in conditional on class on a at bean method. If the class is absent, loading the annotation metadata itself throws a class not found exception. At the method level, always use the name attribute with a string class name instead. Conditional on missing bean is the single most important annotation in the auto-configuration model. Because auto-configuration runs after your application's own configuration classes, any data source bean you define will already be registered by the time boot evaluates this condition, so boot steps aside. This is the override mechanism you customize by declaring your own bean, not by forking boot's code. Conditional on bean is the positive counterpart. JDBC template is only created when a data source is already present, which is the only case where it makes sense. Conditional on property ties bean creation to the presence or value of an application property. The match if missing attribute is the key design decision. When set to false, the condition fails if the property is absent, making the bean opt-in. When set to true, the condition passes if the property is absent, making the bean opt-out. You must explicitly set the property to a falsy value to disable it. Choosing the right default for match if missing determines whether a feature is enabled or disabled by default. Let's recap the key takeaways from this masterclass. If this helped you, hit the like button, subscribe for a new deep dive masterclass every week, and forward this to a teammate who would find it useful. Drop your questions in the comments. I read every one. See you in the next one.